In this video, we'll talk about dictionaries and sets. For strings, lists, and tuples, we have been using integers as the indices and position numbers in order to get their values. Dictionaries are similar to lists, except that instead of using integers as the indices, dictionaries can use any string or number or immutable type as the index. Let's create a dictionary to demonstrate how it works. We will create a dictionary called states. Instead of using number indices, we will use the state's abbreviation as the index and the state's full name as the value. An index in a dictionary is called a key. The values in a dictionary are still called values. As a result, we call the individual elements of a dictionary key-value pairs. First way to create a dictionary is by creating an empty dictionary. After creating the empty dictionary, we can assign new keys to new values. States equals a couple of curly braces, states bracket MA bracket equals Massachusetts, states bracket CA bracket equals California, and last but not least, states bracket TX bracket equals Texas. Here I created an empty dictionary using a pair of curly braces. Every key points to a specific value. We can print this dictionary. Print parentheses states. When we run the program, we see how a dictionary is formatted. A dictionary is enclosed by a couple of curly braces. Each element of a dictionary has a key, followed by a colon, followed by the key's value. Each element is separated by a comma, like a list. Every key has a value. Another way to create a dictionary is to assign a variable to a dictionary with a few key-value pairs. For example, let's delete the snippet of code. Now we'll write the same dictionary that we deleted, except we'll pre-populate the dictionary instead of assigning separate keys to separate values. States equals curly braces, inside the curly braces, MA, colon, Massachusetts, comma, CA, colon, California, comma, TX, colon, Texas. Then we can write print parentheses states. When we run the program, we get the same dictionary that we printed out with our first method of creating a dictionary. All you have to remember is a pair of curly braces, and then the keys are always followed by a colon and a value. Before Python 3.6, key-value pairs of dictionaries were not stored in order. I'm using Python 3.6, but you might be using a different version of Python, which means that the key-value pairs might not be in order. From Python 3.6 and onward, a dictionary maintains insertion order by default. To access a value in a dictionary, you use a pair of brackets like you would with a list. If I want to get the full state name for California, I would write print parentheses states bracket CA bracket parentheses. When I run the program, I get California because California is the value for the CA key. You can delete key value pairs like how you would delete values of a list. Let's try to delete the MA Massachusetts element. DEL space states bracket MA bracket. We can print out states. When we run the program, the MA colon Massachusetts element is deleted. We can also get the length of a dictionary too. Print parentheses len parentheses states parentheses. When we run the program, we get the length of states, which is now 2. Just like lists, dictionaries are passed by reference. A variable that is assigned a dictionary variable changes the actual dictionary. Let's first delete the DL statement. If I set B equals states, changes to B will affect states. B equals states, B bracket, CA bracket, equals Florida, and we can print states. When I run the program, I can see that the assignment of CA for B changed the state's dictionary. CA is now has a value of Florida. Dictionaries are passed and assigned by reference, not by value. We can use for loops with dictionaries. For I in states, colon, tab, print I. If you use the for loop like you would with a list, I will be the keys of the dictionary. When we run the program, we get the keys from states, MA, CA, and TX. You can get the values separately. If you just want the values, you can use the .values function on the dictionary. For value in states .values, parentheses. Let's delete this first and write this. For value in states .values, parentheses, colon, print value. When we run this program, we'll get the values of states. Massachusetts, California, Texas. Most of the time though, we want both the keys and values. To get both the keys and values of a dictionary, we use the .items function on the dictionary. For key, comma value, let's delete this first. For key, comma value in states .items, parentheses, colon, print parentheses, key, comma value, parentheses. When we run the program, we get both the key and value from states. You can see each state abbreviation followed by a comma, followed by the full state name. Most of the time, I need to grab both the key and value, so I normally format my dictionary for loops using the .items function. We can check if a dictionary has a particular key. Like in a list, we can check for membership in the dictionary. For example, we can check if states has the MA key. Let's delete this and write if, parentheses, MA in states, parentheses, colon, print MA is in states dictionary. When we run the program, we see the print statement MA is in states dictionary because MA is a key of the states dictionary. You might be thinking, what makes a dictionary so different from a list? Is the only difference between a dictionary and a list the fact that a dictionary can have different types like strings for the indices? Let's review the main differences between a dictionary and a list. First, we've talked how a dictionary can have different types for its keys. On the other hand, a list is ordered with numeric indices starting from 0. Second, you may have noticed already that dictionary keys are unique. We can reassign and delete existing key value pairs like what we did with states, but dictionary always forbids duplicate keys. Dictionaries are good data structures for holding unique data. In our example, we created a dictionary to hold the abbreviations of states because we know that every state has a unique abbreviation. In contrast, a list can hold duplicate values. Technically, a dictionary can also hold duplicate values, but since the dictionary can only have unique keys, we use dictionaries whenever we have data with unique identifiers. Third, checking for membership in the dictionary is much faster than checking for membership in a list. Checking for membership in the dictionary takes about a constant, fast amount of time, whereas checking for membership in a list takes time proportional to the list's length. I emphasize performance speed in these videos. When talking about computer science in Chapter 1, I said that computer science is about figuring out what can be computed, how can we compute it, and especially how fast can we compute it. Paying attention to performance speeds of every data structure you use is important to being an efficient problem solver in computer science. Let's talk about sets. A set is like a dictionary except it only contains keys. A set is just a unique collection of values. Let's make a set of fruits. So we'll delete all of this and write fruits equals curly brace, apples, comma, bananas, comma, mangoes, comma, oranges, comma, strawberries. You will notice that a set looks very much like a list, except it uses curly braces like a dictionary. You can add new values to a set with the set.add function. We will add a new fruit to the set. Fruits.add, parentheses, pairs, parentheses. And then we will print fruits. When we run the program, you will notice that adding new values in a set does not put them in order. Sets are not about order. If you want to keep an ordered sequence, then use a list. We added pairs, but pairs appeared in the middle of the set. You can remove values from a set, but you can only remove that value from a set if it is already in the set. If the value you want to remove is not in the set, then you will get an error. Let's check for membership in the set, and if pairs is in the set, then we'll use the .remove function. If pears and fruits. We'll delete this print statement first. If pears and fruits, fruits.remove parentheses pears. Then print parentheses fruits. When we run the program, since pears is in the fruits set, we remove pears. We can see that fruits no longer has pears. You can use a for loop with a set. Let's delete this stuff. For fruit in fruits, print fruit. When we run the program, we will get every fruit string in the fruit set. We can see apples, oranges, mangoes, strawberries, and bananas. Let's review the aspects of sets. Sets cannot have duplicate values, so sets are good data structures for holding unique data. Accessing elements of a set is a pain, since sets don't support access by index. Checking for membership in a set is as fast as dictionaries. The big question is, when should you use lists, dictionaries, and sets? Let's ask, do you just need an ordered sequence of items? Then use a list. Do you just need to associate values with keys so you can look, check for membership efficiently, and find the values by key later on? Use a dictionary. Do you just need to know whether or not you already have a particular value but without ordering, and you don't need to store duplicates? Use a set. Most of the time, you'll be focusing on lists for ordered sequence of items and dictionaries for unique key value pairs of data because accessing values in a set is just not very flexible. When you know that you have to search your data for membership or you don't want any duplicate data, think about using dictionaries or sets.